Hello and good morning. Well, let's take a look at this. What is z-score? Z-score tells you how many standard deviations, how many standard deviations from the mean, from the average. And if it's a plus, it's above the curve. If it's a minus, it's below the curve. Z-score formula is Z equals some number minus the average divided by the standard deviation. Put a star by that. Okay, let's take a look here. Page 36. This one is a work backwards problem. They give you the z-score, so put negative 0.5 right here. You're looking for x. The average is we need the average. Okay, so let's go to page 36 and see if they tell us the average. Okay, so the average was 56, according to the book. So put average equals 56. The standard deviation is 3. Okay, now we got everything we need here. So what you want to do is solve for x. So you're dividing by 3. So the opposite is multiplying by 3. This cancels. Then you want to add 56 to both sides. So it's going to be 3 times negative 0.5 plus 56 equals the number. So you take your calculator, positive times a negative, that's 1 negative. So I think that's going to be 1.5 plus 56. So it's going to be 56 minus 1.5. And I get 54.5. So the number is 54.5. That is a work backwards type of problem. Make sure you understand it. They give you this, they give you this, and they give you this. So you first multiply, and then you add. And that's it. Work backwards. All right, a normal curve is a normal graph, a normal distribution called a bell curve. Okay? An outlier, let's say everybody scores in this range, and then somebody scores real high. What that does is it brings the average up. So everybody's grades will be inflated, and it doesn't really reflect the majority of the people. So your best is the median. The median is neutral to outliers. Make sure you know that. Okay, before I give you your work, I want you to turn to example 3 in your book. So turn to page 37. All right, so take a look here. On page 37, they give you the average, which is 56. They give you the number, which is 51. And they give you the standard deviation, which is 3, somewhere. So you get a z-score of this. Now the way you work this is, you're going to use a table. So you're going to say the first two numbers here, the first two numbers, you get negative 1.6. And then this third number right here, which is really the second number behind a decimal, is going to be 0.07. Let's see what they did. So they came here to the chart, turned the page, they went down to negative 1.6 right here. And then they took the 0.07, which is the back part of the number, and where they meet gives you this. and you move the decimal 2 places to the right to make it a percentage. So 4.75% of the people scored lower than that person. Okay? And that's how you use this chart. Today's work is right here. If you get stuck, ask, and I'll help you. Let's turn our attention now to college algebra. For college algebra, we're going to learn how to factor what's in common. So in this one right here, you first distribute. So draw your arrows. 3 times 1 is 3. X to the first and x to the second is x to the third. Remember, when you multiply, you add. A positive times a negative, that's 1 negative. 3 times 2 is 6. X1 and x1 is x2. 3x times 1 is 3x. And that should be it. And that's how you do that. Any questions on how to distribute? Okay. Now write this down. X plus x is 2x. X times x is x squared because you have to add the exponents. Here, you add the coefficients. 2 different concepts. Make sure you know that. Okay? Now here we're doing what's in common. To do that, you got to break this up. 2 times 6, 2 times 3, and then x. This one has a 3. So what's in common? They only have a 3 in common. So you're going to factor out a 3. When you take a 3 out of here, you're left with 1. When you take a 3 out of here, you're left with 2 times 2 is 4x squared. And that's how you factor what's in common. Watch again. We're going to do prime factorization. We're going to do 2 times 50, 2 times 25, and 5 times 5. That's called prime factorization. Remember, I told you to use your 2's, 3's, and 5's. Write that down and use these first. All your 2's, all your 3's, and all your 5's. This one is going to be 2 times 2, and then y times y, because you have y squared. So they have a 2 in common, so you take out a 2. They have another 2 in common, so you take out another 2. They don't have anything else in common, so this is your greatest common factor, so it's going to be a 4. If you take out the 4, you're left with 25 in this one. Minus. If you take out the 4, 2 times 2, you're left with y squared, and that's your answer. Now this right here actually can be factored as the difference of 2 squares. Like this is a perfect square. This one is a perfect square, and it's a minus. Now if it was a plus, you can't do what I'm about to show you. So this actually factors as 5 plus y and 5 minus y. And the 4 is part of your answer, so you bring that down. That's called the difference of 2 squares. Let's take a look at another one. This one right here is a perfect square. This one is a perfect square. So the answer is going to be x plus 5, x minus 5. It's always going to be a plus and a minus when it's the difference of 2 squares. This one right here, 4 times 4 is 16. X squared, a power to a power, is going to give you the 4, minus 9 squared. This becomes 4x squared plus 9 and 4x squared minus 9. Now this right here, you can't factor this one anymore because that's a plus, but this one is a perfect square, or the difference of 2 squares. So now you can break this up further. So this becomes 2x plus 3 and 2x minus 3, and then you bring that down. And that's how you do the difference of 2 squared. If you get stuck, ask for help. Today's work is right here, and I'll see you guys in class.